Welcome to our second lecture on Xylem. I did a lot of explanation in the first lecture, and what the first illustrations were good because in the first lecture we had lots of illustrations. In this second lecture we have the notes. Most of the things that you will find in these notes were explained in the illustrations of the first letter. There are, however, a few things I would like to emphasize, and these are the following, or rather to remind you. I presented to you what primary xylem is as opposed to secondary xylem, protoxylem as opposed to metaxylem. What I didn't tell you here are the differences of protoxylem in the shoot and in the root, and the main difference is the longevity. So please read this part to understand this difference in longevity of protoxylem in the shoot and in the root. Okay. We spoke at length about tracheary elements, and I said tracheary elements are not cells. They are a reference to two cells, the tracheids and the vessel members, and we described them when we were at that table. Here you have everything I said during that table in word form, so if you missed anything I said, it's all written here for you. Okay. I explained the fact that having pits in a cell doesn't make the cell perforate. Perforations are at the ends of the cell in what we call a perforation plate, and these perforation plates will be found in tracheary elements. Okay, here again I'm explaining to you the different types of perforations. Please note that perforations are not fixed, they are dynamic, they change. They can be reticulate, they can be scalariform and change, be reticulate, and if everything falls off, then the perforation becomes simple. It just depends on how much solid is left at the perforation plate. Okay, I referred you to a page in your book where we have these the sequence of thickening of tracheary elements. The diagram I've referred to you is on page 65 of your books, and here I've given you in words all the explanations I gave you in the last lecture. Okay. I did explain to you that fibers are cells, but they come in two different lengths, fiber tracheids and libriform fibers. And what I did not point out is the fact that we can also separate them not just by their length, but also by their pits. Fiber tracheids often have bordered pits, whereas libriform fibers often have simple pits. However, there is a gradation between these two. You cannot, whenever you are lost, you are not sure it is a fiber tracheid or a libriform fiber, just call it a fiber. But please know the differences between the two. Okay. I indicated to you that xylem has parenchyma because parenchyma are living cells, and when I presented xylem parenchyma, I pointed out that in the primary xylem we have axial parenchyma, and in the secondary xylem we have ray parenchyma. Again, may I refer you to your books on page 66 Axial parenchyma is shown on figure 8.2K, and ray parenchyma is shown on figure 8.2A. However, this will not make sense to you until you go to page 69, where this parenchyma is shown in the overall xylem block. Please look at figure 11.11. This is a three-dimensional figure in the sense that we are looking at the stem from the side, from the top, and at a tangent. So this shows you various things that you would otherwise not see if you only made one section. Okay. In this in this figure 11.11, you will, please let's take time to just look at the labels. If you look at your labels, you will see at the bottom where it says parenchyma, and you will see a label where it is showing you parenchyma cells going up. This is axial parenchyma. Now on your right at the top, you will see where they say ray, and when you look where it says ray, you'll be able to see parenchyma cells going from your left to your right. I shall explain shortly how we get these two types of parenchyma. Whilst we are at it, please just look at the following. On your left at the top, you will see fusiform initials and you will see ray initials. These two labels are on the same structure, which is later labeled cambium. So the fusiform initials and the ray initials are part of cambium. But please don't confuse ray initials with the ray. The ray is that part which you learned at high school when they said there are rays from the pith to the cortex. That is the ray we are talking about when we say ray parenchyma. Okay. Now, radial or ray parenchyma is made up of two cell types. The cell types are said to be procumbent or upright. This only explains the shape and location of these cells when they were produced in the cambium. Let me show you these in the diagram that follows. In purple here, I've shown you a cambial cell. This shape is said to be fusiform. That means it has these sharp edges. So this is a fusiform cambial initial. Cambial being part of the cambium, initial, it is going to give rise to more cambium cells. Now, if this cell is going to give rise to other cells, it has to divide. Allow me to move quickly from here. I'll come back to show you this fusiform initial in 3 dimensions. Then it will be easier to understand. Okay, here is the fusiform initial, and if it undergoes periclinal division, that means if it is cut along the long along its length, we get 2 fusiform cells. However, sometimes this cell is also cut, or it divides tangentially. When it divides tangentially, it is going to give us 2 types of cells. The cells at the top that have got this cone-like shape, these are the procumbent cells, or the standing cells. And then the cells that are in the middle are more box-like, and these are the ray cells. So the ray parenchyma will come from here, and this will be procumbent ray parenchyma, and this will be ordinary ray parenchyma. So this is the cell, and these are the divisions. In reality, they don't divide like that. This is biology. Things don't come out in perfect boxes, but it is a box-like shape. So we get this parenchyma here. Let's go back to this diagram again. So now we have seen where this upright ray will come from, and where this procumbent ray will come from. Procumbent meaning it is lying down, and upright meaning it is standing up like that. Now sometimes the ray is all just one type of cell. That means it is all procumbent. If it is all procumbent like you see here, then it is a homocellular ray. But if it is like what we see here, where we have upright and procumbent, then this is a heterocellular ray. There is nothing complicated about this. It's just the terminology we never run out of in biology. After I've told you this, I would like us to go back to that figure 11.11, and when we look now on the tangential section, we will be able to see the upright rays and the procumbent rays. They are shown right there. They're not labeled, but now that I've shown them to you, you can see them. And you can see on the cambium itself a single initial that has divided in this way to give you these heterocellular ray. You can see a cell that looks like this, just where that small jutting out bit, if you look at it, you will see a number of ray cells all over that block. Please, after all the explanations I did the last time, I request you to read all of this, and if you really have questions, then post them on the group we made on WhatsApp, and I'll answer your questions. Thank you.